record on this computer. Okay, we're going. Hi. Yay. Welcome to math class, everyone. Today we're going to be doing module 1, lesson 4, order of operations. And we have a special guest today. Would you like to introduce yourself?
Sure. Hi, I am Ms. Nan. I'm another teacher at Five Keys, and I'm also mentoring your teacher as he's developing his capacity as a math teacher, in addition to the other types of teaching he's done in the past. So yeah, thank you for having me here.
Great, cool. And so Ms. Nan will be helping in from time to time. Okay, here we go. Order of operations. Our text uses a mnemonic device. A mnemonic device is a way in which to memorize things called PEMDAS, P-E-M-D-A-S. We're going to talk about PEMDAS. We're also going to talk about another mnemonic device called GEMS, just to give you a quick introduction to help us learn order of operations. Okay, so what is order of operations first and foremost? Let's pull up our trusty whiteboard here. We've been dealing with numeric expressions. So what's a numeric expression? A numeric expression is a series of numbers, like we've been seeing, that doesn't have any letters in it. It's all numbers and symbols, okay? So 3 minus a negative 4, that's something that we've been doing in the earlier lessons, right? All numbers, all symbols, this is a numeric expression. There's something else called equations. And equations means that there's an equal sign involved. So you might have one thing on one side of an equal sign and something similar on another side, right? This is a numeric equation. And we're also going to introduce later algebraic expressions, which are going to have letters that are going to represent numbers that we don't know what they are just yet. But right now we're just dealing with numeric expressions, and where we've only seen them with one operation, like 3 plus a negative 4 or 3 minus a negative 2, we're going to begin to see them with multiple operations in them. So something like this: 3 times 2 plus 4. As you can see, we have 2 operations here. We have the multiplication between the 3 and the 2, and then we have an addition added to this. You may see something else. Let me write another one that's maybe a little bit better. 4 minus 2 times 3. And if you notice, I changed the multiplication symbol from an X to a dot. We've seen this before. This is a notation that means multiplication, all right? So this is a numeric expression. There's 2 operators in here. There's subtraction and there's multiplying. So how do we do that if there's multiple operations? Okay, our instinct might be to work from left to right. Why? Because that's how we read, right? We read from left to right. That's not how we do mathematics. Mathematics has a separate order in which we follow, which is the order of operations, okay? So our text uses this, this mnemonic device I was saying earlier called PEMDAS, which tells us that the order is P-E-M-D-A-S, right? So what do these things stand for? I can't spell parentheses, but the P stands for, we're going to do parentheses first. I think I spelled it right? The E is going to stand for exponents. We'll talk about what that is in a second. The M and the D stands for multiplication and division. And the A and the S stands for addition and subtraction. Okay. Okay, so we're not going to worry about the parentheses and the exponents just yet. We're just going to look at multiplication and addition. So multiplication and division come first. Addition and subtraction come second. So if I look back at the numeric expression that I just listed on the whiteboard, I have 4 minus 2 times 3. I have 2 operations in here, multiplying and subtraction. Multiplication comes first, in accordance with PEMDAS. And then we're going to subtract. So I'm going to do this in 2 steps. First, 2 times 3, 4 minus 6. Then I'm going to come down to addition, subtraction. 4 minus 6, negative 2. So I know that 4 minus 2 times 3 is equal to negative 2. I'm going to show you the wrong way of doing this now. This is the wrong way, would be to work from left to right and say 4 minus 2 is 2 times 3 is 6. That is the wrong way.
This is what happens on social media. People have huge arguments about, have you seen those on like Facebook?
On Facebook, it happens all the time.
It's like, but you all are gonna know. You're gonna be right.
Yeah, that's right.
By knowing, by watching what Mr. Colucci is doing here.
Okay, so what else do we want to cover? All right, so before we jump into our worksheets, let's talk a little bit more about parentheses and exponents. Well, before we do that, let me write out gems over here, okay? This is the other way of working. Okay, so parentheses. We've seen parentheses a little bit thus far. We'll talk about them a little bit more now. I need to pull up my pen here. We may see something like 4 times 3 plus 6. And I'm going to write in the multiplication symbol that we just talked about, this dot, in between the 4 and the parentheses so that we know that that's multiplication. In truth, however, if you ever see a number next to a parentheses and there's no operator there, we assume multiplication. So I don't really need to write in this dot, but I will. Okay, so we have 2 operators going on here and a parentheses. We have addition and we have multiplication. Order of operations tells us to do multiplication before addition, true, but it tells us to do whatever's inside the parentheses before we do anything else. Okay. So I'm going to do what's inside the parentheses before I do anything else. And that happens to be addition. So even though addition becomes after multiplication, I'm going to do it first. 4 times 3 plus 6, which is 9. And now I only have one operation left, which is multiplication. 4 times 9 is 36. Okay, let's talk about gems for a second now. Gems is the same thing as PEMDAS, except it changes up the wording a little bit. Instead of parentheses, they're telling us G, which stands for group.
I've also heard it like grouping symbols, like just grouping symbols. Yeah.
Yeah, group. So what's a group or what's a grouping symbol? The parentheses, that's the big one. That's actually the most common one. And there's 2 more I want to introduce you to right now. The first one of the 2 are brackets. There are moments where you might see a bracket and it looks like this, right? That's going to have the same function as a parentheses. That's also a group. Why might they use brackets? Why might a mathematician use a bracket? Well, if there's something going on inside of the bracket, that also requires the use of a parentheses. I'm going to put a 2 out here. Sorry, that's a little funky. They may use brackets to distinguish them from the parentheses that are inside the bracket. Okay, just know that when you see a bracket like that, it also is a group, and it's going to, you're going to have to do that operation before you do anything else. Okay, it's going to come first. The other one, which is a little bit trickier, but it's important, is anything that has to do with a fraction. So if you see something like 3 plus 4 all over 2 plus 5, we've come to learn that this fraction sign is almost the same as division, right? And division is going to come before addition. However, if there's operators going on either above or below that fraction sign, we assume that there's a group here. But the mathematician might not always write it in. So this addition needs to happen before the division does. So I would do the division first. That's 7 over 7. I'm sorry, I would do the addition first, 7 over 7. Then I could do the division. 7 divided by 7 is 1. All right. So that's parentheses, and that's why sometimes people prefer to use the word group. There's no difference between PEMDAS, that stands for exponents. We haven't seen it in this course yet, an exponent. So you've probably seen it in previous math classes that you've taken, but let's introduce it very, very quickly right now, and we'll come back to it when it comes back and forth, okay? We know that when you put a number next to a parentheses like this, it means multiply. This means literally 3 of 2, right? Or we can also say 3 times 2. Or we could even say 2 plus itself 3 times. Pull my whiteboard. So we would have 2 plus 2 plus 2. And that would give us 6. So what goes on with an exponent? What happens if I were to say 2 to the 3rd power? And that's the language that we use to describe exponents, all right? We write it what's called superscript to the right. Superscript means it's a little bit smaller and it's raised up. So 2 to the 3rd power, that's an exponent raising 2 to the 3rd power. This means 2 times itself 3 times. 2 times 2 times 2. 2 times 2 is 4, times 1 more 2, that's 8. Okay, I don't want to go too far down that rabbit hole because that's not necessarily what this lesson is about, but that's a very brief introduction. The only other thing I want to say about it is oftentimes when we are when we're typing in mathematics and we don't want to do the superscript thingy because we're working too fast and we don't want to have to worry about formatting. Oftentimes you'll see it like this: 2 caret 3, and the caret is shift 6 on your keyboard. So if you're typing and you can't find the superscript or it's taking too long, you can always use that notation to denote an exponent. All right, but again, we're going to come back to that. Okay, so that was the exponent game right there. I'm going to erase all that real quick. All right. Next, we have multiplication and division. We talked about that at length, and addition and subtraction. And so let's just talk about why GEMS doesn't use division. It doesn't use division because multiplication and division are the same step on the order of operation. And this comes up in those silly Facebook puzzles all the time. When we see multiplication and division in one numeric expression, so if you have 6 times I'm going to use the dot to represent multiplication, divided by 3. So what do we do first? Do we do multiplication? Because that's the list in PEMDAS. We don't. We work left to right. So maybe I should have done this instead. Six. We work left to right. Okay. So this is the same step. Here it only lists as multiplication so that you have to think about division as sort of a sister component to multiplication. So 6 times 3, 6 divided by 3 is 2, times 2 is 4. If I had done multiplication first, I would have ended up with 6 divided by 6 and 1. That would not have been correct. Most mathematicians won't write an expression like this. They'll use fraction signs instead, and it'll be a little bit more clear, even without order of operations, what the answer is. But just so you know, multiplication, division, same step, you work left to right. That's why GEMS doesn't include both multiplication and division. And the same thing with the S, subtraction. They're not including addition because they don't want to confuse you, all right? You work left to right with addition and subtraction as well. I'll really quickly to model that. If I have 6 minus 3 plus 4, I'm going to do the 6 minus 3 first. That's 3 plus 4, that's 7. If I had done the addition first, things would have gotten really weird, all right? So addition and subtraction, same rule, work left to right. Okay, I think that's my spiel. Ms. Nan, would you like to add something to it before we jump into the lesson here?
Yeah, so I totally get what you're doing, and I just feel like maybe just for emphasis for students that you are showing what I see is that you're showing 2 mnemonic devices or 2 ways of organizing that are the same thing. They're just different ways of expressing the same rules that will always be the correct order of operations.
That's right.
And I know you said that, but I just feel like for a student, they may wonder for a moment, like, why are you showing me both, or something like that. But I understand why you are, because they both will be, you'll see it that both ways in textbooks or, different.
Okay. Okay, we're back. Sorry, there was a quick little glitch in our in our recording. Did you want to continue in your explanation there, Ms. Nan?
Oh, I think I said it, but yeah, I just wanted to tell you all that these are different ways of expressing the same order of operations that you're going to follow, and so different ways of remembering it.
We're about to turn to the assignment, and they're going to use PEMDAS. But would you say that if GEMS makes more sense to use that instead?
It's funny. I've also heard it GEMDAS, like everything the same as PEMDAS. I kind of think that might be the best, in my opinion.
GEMDAS.
GEMDAS, because you have spelled everything out there. Mm-hmm. You're not dropping out addition and etc. But you also grouping symbols, as you demonstrated, is a more accurate way to express it because it's not only parentheses. Yeah. Cool.
All right, let's look at the lesson then. We should see it on my screen. We do, right, Miss Foster? You see the great, cool. Unit 1, lesson 4, learning target. In this lesson, you will use order of operations to evaluate numerical and algebraic expressions. Okay, let's look at the rugby club example here. The rugby club orders 20 new jerseys. The manufacturer charges a $100 setup fee and $15 per shirt. The total cost is represented by the equation C equals 100 plus 15N, where C is the cost in dollars and N is the number of jerseys ordered. Pedro and David calculate the amount the club owes. So before we move on, this is an example of an algebraic expression versus the numeric expressions we've been working with. because it has letters and numbers in it. All right. So here we go. Here's Pedro's calculation. He says C is equal, that's the total cost, 100 plus 15 times 20. He does the multiplication on the 15 and the 20. He adds it to the 100. David has the same numeric expression, 100 plus 15 times 20, adds first and then multiplies. Where are they different? Well, David is adding first and Pedro is multiplying first. Who do you think made the error and why? Well, we know from PEMDAS or from GEMS that multiplication is going to come before addition. So Pedro's calculation is the correct one.
I want to also point out that if you can scroll back up to that expression above the picture, the algebraic expression, I just want to clarify for students that, so the algebraic expression was C equals 100 plus 15n, and then the example is where the n has been replaced by 20 because that's the number of shirts. So that's what happened between that first algebraic, not expression, but rather equation. And then these examples here are with a specific number 20 put in place of that variable n.
Yeah, we're going to do a deeper dive into that later, but that's what's when we get to evaluating expressions. Okay, vocabulary. So operation, mathematic processes used to solve problems. The four basic operations are addition, subtraction, multiplication, and division. So when I talk about an operator, as I've talked about before, those are the four basic operations that we've spoken about. Order of operations, I'm going to, for the sake of time, scroll down a little bit because we've done some of these examples already. PEMDAS, we talked about that. So go ahead and fill that out as you work through this. And here's another problem for us to try. So let's give it a go. Joshua says that 5 minus, it's a subtraction sign, a -6, that's the 6 to the left of 0 on our number line, and 6 units away from 0, times 4 plus a -3 is 41. Sarah says it's equal to 26. Who is correct? All right, so what comes first in our order of operations? We have subtraction, we have multiplying, and we have addition. So we're going to do our multiplication first because it comes before addition and subtraction. So we have 5 minus a -6 times 4, and we know from our previous unit that a negative times a positive is a negative number. That ends us with -24 plus a -3. Okay, so now we have subtraction and addition, and we know that happens in the same step in order of operations. And when we see them together, we're going to work left to right. So the first thing we're going to do is the one furthest to the left. That's the subtraction problem. We've learned that subtraction means to add the opposite number. The opposite number of 24 is positive 24. So if I want to use the bop rule, I can. I'm going to make this an addition and this a plus sign. 5 plus 24 is 29. Not 25, silly teacher. Plus a -3 still. And we know from our previous lessons that when we're adding numbers that have different signs, we're effectively subtracting. So 3 off of 29 is 26. And the bigger number is going to give us the sign. It's a war, not a party. So that is 26. Sarah is correct. Okay. Let's give this next one a shot. Yeah, let's do this next one. Let's clear that. Bloop. Okay, so here we have a subtraction, an addition, and an exponent. All right. I do want to point out, I should have said this earlier, that even though there's parentheses here, there's nothing to do inside the parentheses. So when we talk about doing what's in the group first, we do what's in the group, not necessarily what's being asked of us outside the group. Okay, so subtraction's our operator here. That's what we're going to follow with the order of operations when it comes to dealing with this parentheses. If there was something to do inside those parentheses, we would do it first. And we'll see an example of that coming down in a second. Okay, so between subtraction, addition, and exponents, we're going to do the exponent first. This is 5 times itself 4 times. 5 times 5 times 5 times 5. Well, I know that 5 times 5 is 25. And I know that 5 times 5 is 25. So now I'm left with 25 times 25. I don't know what that is off the top of my head. So without any fear at all, I'm going to pull up my Mathway calculator here. And I'm going to actually practice using exponents. So instead of doing 25 times 25, I'm going to use that caret symbol that we talked about earlier in order to do this calculation. You see how I hit the caret and it made the superscript for me. And there's my 5 to the 4th power. I'm going to evaluate 625. Okay, so I know that this is 625. Okay, so I have -3 minus a -6. We don't actually need that parentheses. I'm just going to use it to keep things clear. 625. So now I have 2 operators. I have a subtraction sign here and an addition sign here. Okay. Sorry, it looks like an equal sign. But we know that when we're dealing with addition to subtraction, they're on the same step in the order of operation. So we're just going to work left to right. So -3 minus a -6, we're going to add the opposite. That's going to become a +6. I'm going to end up with 3 plus 625. And my answer is going to be 628. Okay. For the sake of time, I am going to, I think, just talk through this very quickly, and then we'll do number 2 together, and then we'll do number 3 together as well. Oh, yeah, well, I'm gonna leave you to your own devices for number 3, but let's talk about number 2. We have we have 3 operators. We have multiplication, we have addition, and we have division. We know that multiplication and division are going to come first in our order of operations, and we're going to work them left to right. Once we do that math, then we'll add. So we'll do these 2 guys first, and then we'll handle this mathematics, and then we'll add. Okay. All right, let's look at number 2, because this is where it gets kind of interesting. I think it does anyway. And I'm going to use GEMS as my mnemonic device for this case. We have an addition sign, we have an exponent, we have multiplication, we have subtraction, and we have parentheses, which are grouping. So what comes first? The group does. 3 plus 2, 5. I still have my exponents there. Times 6 minus 1. I have 3 operators here. I have a exponent, I have a multiplication sign, and I have a subtraction sign here. What comes first? The exponent does. 5 times 2 is 25.
5 to the second power.
Oh, thank you. 5 to the second power is 25 times 6 minus 1. I have multiplication, I have subtraction. 25 times 6 is 150. Minus 1, 149. Okay, number 3 is asking us to convert mixed numbers to improper fractions. Oh my gosh. Okay, we're not going to do a deep dive in this because this is a class within itself. There's a link here for you for converting mixed numbers to improper fractions. You can check that out. You can let me know if you're still having a hard time with it, and we can work independently. And I can get you some resources for learning that, but it's not the focus of this lesson. So I do want to roll by it. Place parentheses to make the largest and smallest value for 7 minus 2 plus 3 squared. Okay, this is kind of a fun one. What would be, well, what are the options here? Place parentheses to make the largest and smallest values. I think that there are, correct me if I'm wrong, I think that there are 3 places we could potentially put these parentheses. So let's list them all, and then we'll figure out which one makes the largest and which one makes the smallest. We can put them around all the numbers. We can put them around the first 2 numbers, which wouldn't change the value much, I don't suspect. We can put them around the second 2 numbers.
I see one more option now that I think about it.
It did put it onto the left of the negative sign.
Oh, actually, I didn't think of that one. They're more, that's a 4. I was thinking, I guess I could show you, but I was thinking like, just like the last one that you did, the one on the right, but then if you moved that parentheses to the other side of the exponents, I think that then that would change the value.
Okay, great.
Just saw that. It's what's kind of fun about doing it together, because kind of see more things that way.
Yeah.
But I also heard what you said, like you could do it.
I think
your idea.
I don't like mine, and I don't want to get too into
Okay.
it because I think it'll change the subtraction sign to a negative sign, which I think is
Okay, leaving it as an operator.
Yeah.
Okay.
So like this. Oh, and then you can actually do a lot of variations on that, right? You could put it here.
Well, yeah, that's right where you have, like I was saying, just to the left of that 2, but to the right of the negative sign. Yeah, that was the one I had in mind.
All right, let's look at these 4. There's actually a few others now that I realize that you could go to the far right. I just didn't consider that before. There's putting it just over the 3, putting it here, and putting it here. This problem actually could take a minute. So 7 minus 2 is 5. We're going to do what's inside the parentheses first, right? 7 minus 2 is 5, plus 3 is 8. 8 squared. 7 minus 2 is 5. Plus 3 squared. Here we have 7 minus 2 plus 3 is 5 squared. And here we have 7 minus, I'm going to do this math for you. 3 squared is 9 plus 2 is 11. But the exponent's gone at this point. Okay, here we're going to have 64. Between addition and the exponent, I want to do the exponent first. That's 3 times 3 is 9, plus 5 is 14. Here we have subtraction and an exponent. We're going to do the exponent first. 5 times 5 is 25. It's a 7 minus 25 is negative 18. And 7 minus 11 is negative 4. Okay, so we're going to look at our answers here. I'm going to use different colors so that we can see a little bit more clearly. We have 64 so far. That's the highest. 14, negative 18, and negative 4. There are 2 other ways in which we could organize this. We can put the parentheses here, or we can put the parentheses outside of this 7, right? I'm going to leave that to you, class, okay? So if you want to try to do some variations on this, by all means, play with it. The point of the exercise is to see how or grouping things differently is going to so dramatically change the outcome, all right?
I want to just comment to that. I know students often get confused about this. The smallest value is going to be the most negative number. That's something I've seen students get confused about before. So I just thought I'd mention that to point that out, that like, because you might say, oh, well, 14 is smaller than 18, 18 is bigger. But of course, we're talking about most negative is actually smaller.
And we reviewed that in our first module, right, class, the idea of absolute value, and the absolute value of 18 is greater than the absolute value of, the absolute value of negative 18 is greater than the absolute value of 14, but negative 18 is in fact a lesser number because it's further to the left on the number. All right. Let's clear this drawing for a second. We discussed what an expression is. We discussed what an equation is, and the difference between algebraic and a numeric equation. So we're going to skip down to that. Okay, and then this is what Ms. Nan was talking about a little bit earlier when we saw that first example with the rugby uniforms. All right, but what it means to substitute a given number whenever you see the variable and then solves. This is what we would say evaluating an expression. So we're going to evaluate an expression. We're going to evaluate the following expression for x is equal to 2, meaning that whenever we see a 2 in the algebraic, whenever we see an x in the algebraic expression, we're going to substitute a 2 into it. Okay, so just like they did here, here's x to the 3rd power. There's our superscript 3, meaning that this is x times x times x plus x to the 2nd power, x times x plus 1x, okay? And here they go. Every time they see an x, they put in a 2 instead. 2 to the 3rd power plus 2 to the 2nd power plus 1, 2, right? A2. Here we have 2 times 2 times 2 plus 2 times 2 plus 2. Whole lot of 2s. But that's the idea of evaluating an expression, substituting it in. That's 2 times 2 times 2 plus 2 times 2 plus 2, and they came up with 14. So evaluate the following expression for y is equal to 5. Okay, we will do a we will do this out for you. So every time I see a y, I'm going to replace it with a 5. Why? Because that's what the problem solving telling us to do. What does 5 squared mean? Does it mean 5 times 2, like I like to say? It doesn't. It means 5 times itself twice, or 5 times 5. $25. And that equals to 30. Sweet. Okay. We're going to clear our drawing here. We're going to scroll down a little bit. Find the value of each expression below, where a is equal to 3 and b is equal to 4. Okay, we're going to do just one of these, and then we're going to, I'm going to take a quick break. It's going to be really fast for you guys. And then we're going to jump into the quiz. All right. Let us do, because we'll do A, all right? Actually, no, we're going to do B. I'm going to do B for a very specific reason that I'll point out to you when we get there. So B is equal to 4 and A is equal to 3. So every time I see a B, I'm going to write in a 4. And every time I see an A, I'm going to write in a 3. All right, so I have 2. I'm going to use a parentheses here. 4 to the second power. I didn't have to use this notation, but I am, because you're going to see similar notation in the practice problems. Minus 7 times 3. Okay, now what comes first? Well, parentheses comes first, but remember what's inside the parentheses comes first. We don't need to multiply the 2 by the 4 first, because that's happening outside the parentheses. It's a very, very important point. So exponents is going to come next. All right. So 4 times itself twice, 4 times 4, 2 times 16 minus 7 times 3. So now we have multiplication happening twice, and we have subtraction. I'm going to do multiplication in the same step. All right. We could, if we really wanted to break it down, we would work this one first and then work this one in accordance with the rules, but the math is going to work out the same. So 2 times 6 is 32. 7 times 3 is 21. Now I only have one more operation left, and it's subtraction. 32 minus 21 is 11. And that's our answer. I just want to point out that had we done this multiplication first, thinking that we had to get rid of the parentheses, we would have ended up with 8 to the second power, and that would have given us 64 down here, and we would have been off by quite a bit. Okay, so if you ever see this notation, know that the exponent's going to come first. Okay, now I'm going to pause the recording for just a second. When I do, please open up the quiz. Let's clear this drawing really quick. So here's where we are. And this is how we work, right? We're going to do the quiz on our own. You're going to, once you've done it, you're going to come back and watch me do it. And if you have any questions, you're going to let me know. We're going to take a really quick break. I'm going to put this on pause. You're going to put it on pause and go ahead and do the quiz all on your own for just a second. Okay, we're back. Let's get this quiz going. I hope it went well for you. And remember, these quizzes don't count towards your score, your grade in the class, but you will get extra credit points for doing them. Okay, so here's our order of operations. I like this problem because what I was saying earlier about not applying the exponent to anything that's outside the parentheses. Well, here's an example of when the group comes first. So I do want to do what's inside the parentheses before I do anything else. So 6 plus 3 is 9. That handles the parentheses. There's nothing left to do inside the parentheses. And now I have two operators. I have an exponent sign and I have a subtraction. The exponent is going to come first. So 9 times 9 is 81. Minus 4. And we know that 81 minus 4 is 77. Really quick, or maybe not so quick. I just want to show you that this is also an option for you to check your work. What was it, 6 plus 3? Whoops. Okay, this is a good thing to note. When you are working with a calculator like Mathway or Desmos as well, I think it works this way too. These buttons down here will get it off of superscript. You see how that worked? So I just typed in the problem. Let's see if the computer confirms my my math. 77. Yeah, it did. Okay, so again, I really would prefer that you not use Mathway to just sort of like blow through the course, but is a really great way to confirm your work, that you're doing it correctly, and that and to be able to proceed with confidence. And look, if you need to lean on that tool as much as you need to, I completely approve of it. But don't lean on it any more than you need to, if that makes sense. I think it does. But we have the technology. Oh, right. Okay, so here we have several more operators. We have an exponent. We have addition. We have a group. And then we have division. So we're going to do our group first. 14 minus 4 is 10. Okay, so now I have three operators. I have an exponent, addition, and division. The exponent is going to come next in accordance with the order of operation. 2 to the third power is 2 times 2 times 2. 2 times 2 is 4, times 2 again is 8. Now I have addition and division. We might be tempted to do the addition first because it's to the left and we read from left to right, but we know better. We're going to follow the order of operations. So we're going to do division next. So 10 divided by 2 is 5. And now we only have one operator in this division. 8 plus 5 is going to give us 13. And 13 is indeed an option. So go us. All right. Okay, question number 3. 2x plus y to the second power minus x times y for x is equal to 1 and y is equal to 4 is equal to 18. This is one of those evaluating questions. So asking us to substitute these variables, these numbers in for the variables as we see them, or the unknowns, I should say. So x is equal to 1, y is equal to 4. I'm going to rewrite this algebraic expression. That's the word for this, because there's no equal sign. And every time I see an x, I'm going to write in a 1. And every time I see a y, I'm going to write in a 4. So 2 times 1 plus 4 to the second power minus 1 times 4. Okay, so I have now this is an order of operations problem, right? We have it as a numeric expression. And I have multiplying twice, I have addition, I have subtraction, and I have an exponent. Even though I wrote in parentheses, there's nothing inside those parentheses to do. So these are multiplication steps, not parentheses or grouping. All right, so I'm going to do my exponent first. That's 4 times 4, 4 to the second power. I'm going to rewrite the rest of this stuff in here so I remember it. Okay, now I have multiplication going on and I have addition and subtraction. I'm going to rewrite these multiplications so that they just go away. Okay, 2 times 1 is 2. One times 4 is 4. Now I have addition and subtraction, and I know when I have addition and subtraction, it's the same step. And now I am going to work left to right because I'm at the same step in terms of our order of operations. So left to right, 2 plus 16 is 18. Minus 4, 18 minus 4 is 14. So this is false. Okay, we're going to clear that. We're going to scroll down a little bit. And we have one more problem to get through, and then we are completo, no más. Raymond spends 1/10 of his vacation budget on a car rental. Write an expression for how much he has to spend on the rest of his vacation if he budgets $650 for the vacation. How much will he have left to spend? Huh. Okay. So I'm going to write an algebraic expression, right? I'm sure there's other ways of doing it. How much he has to spend on the rest of his vacation. Okay.
It looks like an equation, actually. I feel like it's an equation. Like, and yeah, it seems a little advanced for this, or like it almost belongs in another assignment a little bit. Like,
yeah,
we sort of took a big leap here, but hey, it's looking forward.
Yeah, so we're gonna look. Miss Nan is completely correct. This is maybe getting a little bit ahead, but we are going to not use that color because that color I think is hard to see. So we're going to use a different color, but we're going to give this our best. All right. So I'm going to name a variable. I'm going to call it X is going to be equal to how much money this could be an equation, but I think I'm going to do it as an expression. How much money he has, let's use his name. How much money Raymond has to spend on the vacation in total? Okay. So if that's the case, this is how much money he has to spend on the vacation. If I say minus how much money he spent on the car, X times 1/10, well, that's how much money he should have left to spend, right? I think let's see how it plays out. Okay, so I'm now going to evaluate this expression for $650. Okay, where's my handy dandy annotator? Okay, so if I say 650 minus 650 times 110. So now I'm multiplying fractions, and we know that sometimes it's a little easier to multiply fractions if I divide by 1 so that I can see it as a fraction. Multiply the numerators, multiply the denominators, and divide. So I know that this is 650. And I'm doing the multiplication first because that's how what we do in order of operations. Minus 65. And 650 minus 65 is 585. Which is very close, but not quite 584. So the answer to that problem is false.
Cool.
Cool. Yeah, I wouldn't worry too much if that we're gonna build to that over this course. So don't sweat it. Thank you all for your good work. I'm here for you if you have any questions, or if I'm not your teacher when you're watching this video, your teacher is here for you. I know they are. Thank you, and I will see you for module 1, lesson 5 at a later date. Ciao. I'm still recording. Okay.